Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go.
Welcome to Real GMAT Problems, episode 30. Doing real GMAT problems is one of the fastest ways to make test day easier and better, so let's talk through a few examples. The problems that we're going to go through today are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions that we're going to work through here. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be very similar to what you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on what to learn from each question. I recommend pausing after I read through each one and trying to solve it, and at the very least, if you're on the go and you're not in a position to try to solve, visualize how you would solve it. You might not be able to execute all the steps in your head as if you were on test day, but just do your best. It's a great mental workout. If you are in a situation where you can physically write down what you would during the actual exam, that's for sure ideal. Let's start with a warm-up problem that's on the easier end of the difficulty scale, and then we'll move up to some more challenging questions. This is problem number 126. The problem says it would take one machine 4 hours to complete a large production order, and another machine 3 hours to complete the same order. How many hours would it take both machines working simultaneously at their respective constant rates to complete the order? Let me read that again. It would take one machine 4 hours to complete a large production order, and another machine 3 hours to complete the same order. How many hours would it take both machines working simultaneously at their respective constant rates to complete the order? Option A is 7 over 12. Option B is 1 and 1/2. Option C is 1 and 5/7. Option D is 3 and 1/2. And option E is 7. Again, I recommend pausing here and trying the question on your own. It's definitely not the easiest rates question that I've ever seen here, but also not terrible if you've studied a little bit of how to do rates questions well. Having said that, if you're just starting out, there are a few key concepts that I think you'll find really helpful for these types of problems. The first concept is what happens when people, machines, or robots, whatever the case may be, are working together. Think about a simple example. Let's say a robot can wash 5 cars in an hour, and another robot can wash 7 cars in an hour. If they both wash continuously for an hour, how many cars do they wash together in that hour? Hopefully you're thinking 12, which is right. And if that's strange or hard to wrap your mind around, just imagine one machine over here washing 5, while at the same time, right next to it, the other machine is washing 7. That should help you understand the principle behind the math here, which is we want to add the individual rates of things working together to find their combined rate. Again, when two people, machines, or whatever are working together at the same time, you can add their individual rates to figure out their combined rate of production. This is a really common and very helpful move to make in many GMAT rates questions. If they're not working at the same time, that's different. So that's an important caveat here. You want to make sure they're working simultaneously. Most of the time, the problem's going to say that. And you can see that word literally in this question, working simultaneously at their respective constant rates to complete the order. So that's your cue that you're probably going to combine the rates at some point in this problem. There's a lot more to discuss there, actually, because there's a wide variety of ways that rates can be combined, and there's also a few different situations where it can happen. So I'm just going to focus on the basic core principle that we just outlined today for the sake of simplicity, and I imagine we're going to end up covering most of the ins and outs of the other situations as we progress through this series. Um, if you are in a rush, though, and you want to get better at rates right away, there's plenty of free and paid material out there on the web, and you're probably just a few web searches away from some material that's going to really help you out with that. If you want to go a little bit deeper than we're going to go today, but for now, let's stay focused on this problem and just this one core concept of adding rates. The second key to the game in rates questions is the basic formula of rate times time equals distance. Same formula, rate times time equals work. Work and distance are somewhat interchangeable on the exam, and it really is just the flavor of question that you're working on that determines which one's which. Let's give an example. So in a distance question, imagine you're traveling 50 kilometers per hour for 2 hours. It's probably pretty intuitive for you to think that you're going to travel 100 kilometers during that time. This is the kind of math that we end up doing on a day-to-day basis. It's the kind of math behind what makes your estimated time of arrival work on your Maps app on your phone. It's that kind of thing. Similarly, if you can type 5 pages per hour and you type for 3 hours straight, you'll probably be able to figure out that you will have typed 15 pages during that time. So that's just rate times time equals distance, or rate times time equals work. They're very related concepts. You can even think of them as the same concept, just labeled differently. The vast majority of the time, if not all of the time in rates questions, you're going to end up using that rate times time equals work relationship. So it's a good idea to be super, super familiar with it. Let's explore a potential solution path using those two keys that I just talked about for this problem. If we know that we want to add the individual rates of the machines, but we're not given those rates, then it's likely we're going to need to solve for the rates first. Note that here we're given the time and the work, but not the rate. That's fine, though, because if we know rate times time equals work, we're going to be able to solve for rate if we are given time and work. So let's do that for both machines. For machine 1, we're told it takes 4 hours to complete one order. And if we put that into the rate times time equals work equation, we would have R for rate times 4 equals 1. Or if you like writing units, R times 4 hours equals 1 order. I highly recommend writing units in rates questions. I'm never going to argue with your results. If you're getting insanely good results without writing units, great, don't change. But most people benefit greatly from writing units down in all word problems, rates questions in particular. It's just really easy to get turned around with the right numbers and get the question wrong, which it hurts. If we divide both sides of our equation here, R times 4 equals 1, or R times 4 hours equals 1 order, if we divide both sides by 4 to isolate the rate, we would get R equals 1/4 of an order per hour. And that's another advantage of tracking the units, is it can help you validate that your calculations are correct. So the rate of the first machine working alone is 1/4 of a production order per hour. Let's do the same math with machine 2. We're told it takes 3 hours to complete a production order. We can express that as rate times 3 hours equals 1 order, or R times 3 hours equals 1 order. So if we divide by 3 to isolate the rate on both sides, then we would figure out that the rate of the second machine is 1/3 of an order per hour. If you're just getting going and it's been a while since you've done algebra, we've got a Math Basics episode to help you reskill, linked in the description of this content. And we all start somewhere with the exam. Might have been a while since you thought about doing some algebra or dividing both sides of an equation by anything, and it might be might be helpful to brush up on that before you proceed with this lesson. Up to you, though. So we got machine 1, 1/4 of a production order per hour, machine 2, 1/3 of a production order per hour. That's great news, because now we have the rates of both machines and we can add them together. To add 1/3 and 1/4, we just need to find a common denominator. If you're not sure how to do that, happy to walk you through it in the Math Basics episode linked below on fractions. So we've got basically all the math essentials that you would need that you might be a little rusty on in that Math Basics series, and that'll get you ready for the math that you're going to be doing on test day. So I'm going to gloss over that here. Not going to talk about common denominators here. Just going to assume you know that. Again, if you go listen to that episode and come back, it should make a ton of sense. If we do add 1/3 and 1/4 by getting a common denominator, we're going to wind up with 3 over 12 plus 4 over 12. That would get us 7 over 12. And right there, you might see why a good number of us end up going for option A incorrectly, which is 7 over 12. And believe it or not, even though this isn't the hardest problem in the book, so to say, 14% of us are going for option A. Just going to drop that there. But unfortunately, that is not the answer because the question is not asking for the combined rate of the machines. It's asking for the combined time that it takes them to complete the order together. And so far in this series, I've probably mentioned it about 1 billion times. But on word problems, just make sure you're writing what's asked and given really clearly at the beginning of the problem. That'll help you from solving for the wrong thing, which is a huge, huge problem. That's also, coincidentally, why I was recommending that you write units next to everything you're computing in word problems and rates questions. You don't have to love it. I want to be clear about that. Like I'm not sitting there taking the GMAT or doing GMAT problems, preparing for this kind of instruction with all of you being like, oh, I can't wait to write these units down. It's going to be awesome. It often feels like a pain in the neck, especially after a long day or start of a long day, like whenever you might be studying, when you're trying to cram this in on your lunch break. It's difficult. That's the whole point, is it's difficult. And that's part of the reason the exam exists. Schools know it's difficult for you to do this stuff. And so if you can perform well on this, then they know you're like a very bona fide candidate, basically. So it's obviously not the whole part of the application. It's just one piece of the application, but it's a very, very important part of the application, depending on which schools you're applying to. And you can do some research to figure out how important the GMAT is at your target schools. But if you're looking at the top 20, having a great GMAT score really helps. So plenty more we could say about that, and I'm sure plenty more that we will in due course. But all that's to say, if you do the math on your lifetime earnings with an MBA versus without an MBA, or with a top MBA versus a not so top MBA, then I think you'll start to see the value of writing the units down in your rates questions. Okay, so if you need some inspiration, that can probably do it. So let's circle back to why the answer is not A, and how we're going to get from 7 over 12 production orders per hour to the amount of time it takes, which is what the question's asking us to solve for, not the rate. So what we can do is just use another instance of the R times T equals W equation, meaning rate times time equals work. So this time we know the combined rate and we know the work, but not the time. So we'll set up 7 over 12, that's their rate, times T, an unknown amount of time, equals 1 full order, which is the amount of work that we're being asked about. So if 7 over 12 times T equals 1, in order to solve, we just divide both sides of the equation by 7 over 12, and that would get us T equals 12 over 7 times 1, which is, of course, 12 over 7. Now we just need to convert that into a mixed number. In order to do that, because that's the way the answers are expressed, we just divide 7 into 12. It goes in one time with a remainder of 5, and that gets us to option C, as in Charlie, which is the correct answer, 1 5/7. If you want help reskilling or upskilling with remainders and or dividing by fractions and or mixed numbers, we've got Math Basics episodes on all of that linked for you below as well. And when I was starting to study for the GMAT, it took me a while to shake the rust off all that stuff. Even though I studied a lot of math in high school, I did a lot of math in college. Many of you haven't taken math since, it's been a while, and that's totally fine. But even me having taken a lot of math in college, it had still been quite some time, enough time that I had basically forgotten how to do math by hand and had to relearn a lot of this stuff. And pretty much everybody's in that boat when they start studying. So don't worry about that. Just start the process, get it done. And if you're finding that you're having resistance to it, just treat it like a job. If treat this whole GMAT MBA thing as an assignment you got from your manager at work to help you improve, help you get that next promotion, maybe a couple promotions. And I think that's a good attitude to have with it. Like I said, it's awesome if you enjoy the process. A lot of people do, but you don't need to enjoy the process in order to get great results. Just gotta put yourself in the seat and make it happen. So honestly, that's the long and short of that question. It's a great warm-up problem because hopefully it'll teach you, or maybe just remind you, if you learned this already, two of the most important keys to rates questions. And it's also a great opportunity to practice good execution and labeling of values clearly in order to prevent yourself, from falling into trap answers, of which there are generally quite a few. As usual, I recommend making a quick note to self based on what you'd like to remember from that question. If you could only remember one thing about that question or from what we just discussed, what would you want that to be? If you're on the go, I'd recommend just like text that to yourself, email that to yourself, put it in your notes or make a flashcard out of it when you're in a more convenient situation. Or if you are studying at a desk or similar or on a plane or a train or something, and you can log this in your flashcards or study sheets, whatever you're using to memorize how to be better, I would highly recommend doing that right now. Feel free to pause. And I will move on to the next problem whenever you're ready. This is problem number 127, and the difficulty rating goes up a little bit here, okay? The problem says to mail a package, the rate is X cents for the first pound. So that's the variable X, the letter X. To mail a package, the rate is X cents for the first pound and Y cents for each additional pound, where X is greater than Y. Two packages weighing 3 pounds and 5 pounds respectively can be mailed separately or combined as one package. Which method is cheaper and how much money is saved? I'll read that again. To mail a package, the rate is X cents for the first pound and Y cents for each additional pound, where X is greater than Y. Two packages weighing 3 pounds and 5 pounds respectively can be mailed separately or combined as one package. Which method is cheaper and how much money is saved? Option A says combined with a savings of X minus Y cents. So that's saying the combined method is cheaper and you save X minus Y cents. Option B says combined with a savings of Y minus X cents. Option C is combined with a saving of X cents. Option D is separately, so it's saying it's cheaper to mail them separately with a savings of X minus Y cents. And option E is separately with a savings of Y cents. Again, I recommend pausing here and trying to solve on your own. Slightly more complex problem than the previous one, with quite a few more of us missing this. About 22% of us are getting this one wrong. So it's definitely not the hardest GMAT question you're going to see. But I think given the nature of the math involved and the kind of like, if you think about the school level of the math involved here, I think you might look at this and think it's not that bad, especially if you think about how talented this like pool of applicants is for MBA programs. And yet, quite a few are missing. Quite a few are missing this one. And these are the questions that I think it's most helpful for us to dig into in this series, because a lot of times it's not even that you don't know the material that's causing you to miss those questions. It's something else. So here we go. What's interesting is there isn't one wrong answer that's a clear like trap that most of us fall into, unlike the previous question where it's like the vast majority of the misses are just one wrong answer. Here, the wrong answers are spread out across all of the incorrect answers. And I think that suggests people are generally just lost. They're getting into the math and they're just getting lost. So let's build a process that you can use to create more consistent results in these kinds of situations. There are two main options for solving a problem like this one. You can use algebra, or you can plug in some numbers to replace the variables. Let's talk through both, and then you can decide which one you like better. I'll give some advice about which one I think is better depending on the type of student and test taker you are. I don't think one is inherently better or worse than the other. It's more a matter of preference. But if you want just like a clear, straightforward recommendation, I'll give that in a second. Let's make sure we sketch out the techniques first and then have a chance to compare them side by side. So let's start with the algebra approach. We're mailing two packages, and we know how much they weigh, and we're given the variables to represent the pricing of how much it's going to cost by weight. So we want to find out if it's less expensive to mail them separately or together, and if so, how much less expensive it is. That's what we're given, and that's what we're asked. So let's set up some equations to represent those relationships. First, Let's do the 3-pound package. It's X cents for the first pound, and then it's Y cents for each additional pound. So it's going to be X for the first pound and then 2 times Y for the other 2 pounds, 3-pound package. From there, we can add X to 2Y, and that represents the total cost of mailing the 3-pound package by itself. It's X plus 2Y cents. For the 5-pound package, we can use X to represent the first pound and then 4 times Y to represent the other 4 pounds. That would give us the equation X plus 4Y to represent the cost of mailing the 5-pound package. If we add those up to represent the total cost of mailing both packages as a two separate, but like the total cost, that's going to get us 2X plus 6Y. So that's X plus 2Y for the 3-pound, X plus 4Y for the 5-pound. That's 2X plus 6Y cents to mail them separately. If you're not sure how adding equations works, just check out the Math Basics episode titled Systems of Equations, or just Equations, below in the description of this content, and that should help tremendously. So we want to compare that cost, the cost of mailing them separately, to the cost of mailing them together. So let's think about an 8-pound package if we combine the 3 and the 5 into 1. Again, we can use X for the first pound, and then it's going to be 7 times Y for the remaining 7 pounds. So that would be X plus 7Y. Now we can compare which is larger. We've got 2X plus 6Y mailing them separately, or we've got X plus 7Y mailing them together. If you're not super comfortable with variables in algebra, you might not like this approach at this step because things can definitely get like a little bit abstract here. But recall that we were told that X is larger than Y in the original problem. And notice here that we've got 2X plus 6Y, that's 1 fewer Y, but 1 more X. And then we've got X plus 7Y, which is 1 fewer X, but 1 more Y. So if we take away one smaller thing and add one larger thing, we're going to get a larger result there. So that means that the 2X plus 6Y is more expensive because it adds the larger thing, X, and takes away the smaller thing, Y. Again, that might be a little bit abstract. If you don't like algebra, that's part of the reason that I am going to present you with an alternative to this in a second, but that's the way we could use some good algebraic reasoning to figure this one out. So the answer is it's going to be less expensive to mail them combined. Combined is less expensive. At that point, we know it's going to be A, B, or C. We just need to figure out by how much. And to do that, we can just subtract the smaller thing from the larger thing. So 2X plus 6Y minus X plus 7Y. Again, if you're not sure how to do the math there, just check out the Systems of Equations Math Basics episode. But basically what I would do on my page is I would just line them up vertically. So 2X over X, 6Y over 7Y, just subtract straight down, and that gets us X minus Y. X minus Y is the difference, the gap between the larger and smaller value there. That means combined is cheaper, and it is cheaper by X minus Y cents, which leads us to our correct answer of option A. So that's how you can use algebra. You'll want to be fairly comfortable with setting up algebraic expressions involving variables. You'll want to be fairly comfortable adding and subtracting those if you want to be able to go that route. Again, it's a great solution as long as you're comfortable with it and you don't think it's going to lead to unintended mistakes. It's also worth saying, like, even if you're not comfortable with it today, but you want to get more comfortable with it, all that's between you and being comfortable with this is practice. So don't be afraid to do a lot of practice on your basic algebra skills. If you've checked out the video on our website, then you know that like more problems doesn't always equal higher GMAT score. But for certain core skills, like being good at algebra or fraction math, like those math basics things, you can use a little bit of brute force practice there, and that usually works great. Like I said, that's not the only way of approaching the problem. So if you're less comfortable with algebra, or you just want to compare an alternative approach, here's something you can try. We've actually discussed in the past that anytime there are variables in answer choices, you have the opportunity to replace the variables in the problem with numbers, rather than just doing algebra. The basic steps of that process are: number 1, choose numbers to replace the variables. Number 2, plug those into the problem and compute an answer to the problem. And then number 3, plug those numbers into all 5 answers and see if you can get a match for the answer you got in step 2. That's kind of the basic layout of the technique. That might sound like a lot, but once you practice the approach a few times, I think you'll find it quite straightforward, but it's a big departure from how most of us were taught how to do math as young people. So don't stress if it's quite unnatural or uncomfortable the first few times you do it. It was for me too, but it got easier over time. So, a quick note, we've got a past podcast episode going like really in depth with a few examples of how to do the technique and a little bit deeper explanation of the technique. That's why I'm not going to hash it out in really hardcore depth here, but that's linked below also. Instead, I'm just going to jump right into applying those steps to this question, just in case you've been a long-time listener and you're familiar with the process. So first, let's choose a number to replace the variable. Let's say we're going to make x 10 cents and we're going to make y 5 cents. I'm just choosing those numbers because they seem relatively easy to work with, and the problem tells us that x has to be bigger than y. Just to be clear, though, we could have chosen x as 6 and y as 5, or x as 100 and y as 99. Basically, any number that fits the constraints of the problem is going to work. So my advice is you don't have to think too hard about picking like the quote-unquote perfect numbers if you're going to use this technique. I see a lot of people get stuck or just hamstrung with that. Don't worry about that. Just pick something. You can always change the numbers if it turns out they're not that great. So let's just stick with x is 10 and y is 5. Seems reasonable. Let's use that to figure out how much it costs to ship the 3-pound package alone. If we say it's 10 cents for the first pound and then 5 cents for each of the other 2 pounds, it's going to cost 20 cents to ship the 3-pound package. Let's do something similar for the 5-pound package. It's 10 cents for the first pound, 5 cents for each of the other 4 pounds. So that's going to get us 30 cents total for the 5-pound package. So shipping them individually is 20 cents for the 3, 30 cents for the 5, total of 50 cents to ship them separately. Let's now compute how much it's going to cost to ship them together. 10 cents for the first pound, 5 cents for each of the other 7 pounds, and that gets us 45 cents in total. From that, we can tell that it's cheaper to ship them combined, 45 cents to ship them combined versus 50 cents to ship them separately. And we can then eliminate the options that don't have the right price difference. And the price difference here is going to be 5 cents. So the question says which one is cheaper and how much money is saved. So we know 5 cents is saved if x is 10 and y is 5. So option A, B, and C all list combined as less expensive, like we talked about. So we can eliminate D and E. Now we just have to figure out which one has the right amount of savings. A says savings of x minus y, which works because x is 10, y is 5, 10 minus 5 is 5. That was the savings we computed. 50 cents to mail them separately, 45 cents to mail them together, savings of 5 cents. So no surprise that A is our right answer. We already knew that. Let's compare that to B. Let's assume we were doing the problem for the first time. This is a savings of y minus x, which is definitely wrong because that's going to be negative. 5 minus 10 is negative 5. C says a savings of x cents, but that's also wrong because x is 10 and we know the savings is 5 cents. So that gives us our correct answer of option A as in alpha. So what are some of the advantages of that approach? Well, we didn't need to do algebra. That's one. And we only had to use variables as placeholders for the actual numbers. So the math level drops here, meaning you only have to do basic arithmetic using integers. You don't have to do any manipulating of equations or adding or subtracting equations. And for a lot of people who don't feel super comfortable with algebra, that's great. Some people might prefer the algebraic approach, and that's cool too. I'm just going to encourage you to explore as many approaches as possible to each quant question that you practice. There's a lot of benefit in just asking yourself, is there an alternative approach to the one I just used or the one that's being presented to me here? And even just asking that question can really help your learning process. But when there are multiple approaches you can use, I'd encourage you to walk through each one, like write them down side by side, and just ask yourself, which situations are best for you to plug in numbers and which situations are best for you personally to use algebra. Again, I don't think there's any one universal best way to do these questions. It's all about what gets you personally the best results. And so I encourage you to develop that sensibility through the course of your studies. It's worked great for me and it's worked great for everyone I've ever worked with, which is a truly staggering number of people at this point. Having said that, I know some of you just want someone to tell you the best way. And if that's you, that's totally fine. What I recommend for you is always plug in numbers when there's variables in the answers, because I've just found it's a lot less error prone. So even if you're totally comfortable doing algebra, I have found that in general, If you don't want to do what I was just talking about and practice with varying approaches to figure out which one's best for you and why and in what situations, which I highly recommend. But if you're like, hey, I'm already so overwhelmed here, I don't want to do any experimentation, I'm just looking for someone to just tell me what to do and I'll just do it, then just always plug in numbers when there's variables in the answers. You'll end up making fewer mistakes. And most of us are just much more error prone with algebra than we are just doing arithmetic with integers. That's just what I've seen. So, with all that in mind, I recommend you pause and make any notes to self that you want to remember from that discussion. If you could only remember one thing from that problem, what would it be? Recommend you pause here to make that note. And we'll wrap up with another question that's got a couple pitfalls that are worth preparing for and getting ahead of. This is problem 128. The problem says, if money is invested at R% interest, the letter R being used as a variable, if money is invested at R% interest, compounded annually, the amount of the investment will double in approximately 70 divided by R years. If Pat's parents invested $5,000 in a long-term bond that pays 8% interest compounded annually, what will be the approximate total amount of the investment 18 years later when Pat is ready for college? I'll read that again. If money is invested at R% interest, compounded annually, the amount of the investment will double in approximately 70 divided by R years. If Pat's parents invested $5,000 in a long-term bond that pays 8% interest compounded annually, what will be the approximate total amount of the investment 18 years later when Pat is ready for college? Option A is $20,000. Option B is $15,000. Option C is $12,000. Option D, $10,000. Option E, $9,000. I recommend pausing and attempting to solve on your own. Great problem to cover together since it brings together a few really valuable concepts. The first is that in quant questions, we are almost never given information unless it's necessary for solving the problem. Now, in this case, it's not strictly necessary to use the 70 over R concept that we're told, but it is really, really helpful, and we'll talk about why it's so helpful in a moment. So that first concept is if they're telling you something in a quant question, you probably need it. And the second concept that's important here is being okay estimating when you see words like approximately. It's usually quite painful to calculate exact answers when the problem recommends that you estimate by using words like approximate or closest to. So you want to look out for those. As long as you notice those two elements and you can apply them well, then this problem probably goes pretty smoothly for you. But as you might expect, a full 22% of us are missing this one as well. So let's try to smooth that one out. First things first, a lot of folks are going to see compounded, that word in the problem, and go straight to the compound interest formula. And that's not the worst instinct because that compound interest formula can work. But unfortunately, in this problem, it's likely to be really difficult to solve it with the compound interest formula because the exponent in that formula is going to be 18. So you got to take something to the 18th power. And that's just a place without a calculator. There's no calculator on the GMAT quant section if you're just starting out. That's going to be pretty tough for most of us to do 108 over 100 to the 18th power without a calculator or Excel or some type of computer-assisted device. So even though the compound interest formula can be useful, it's probably going to be much easier to use the 70 over R formula that we're given in the problem. So that's part of the point I'm making about using what you're given. I'm not going to cover the compound interest formula specifically here. I know I just referenced it, and if you're not familiar with it, that might have been confusing. I apologize for that, but it's not strictly necessary to get a great quant score to know that formula. I know a lot of people out there are going to disagree with me. They're welcome to their opinion. My opinion is it's I don't use it very often. I don't recommend using it very often, but if it's working for you, again, I'm never going to argue with your results. But all compound interest questions can be done in multiple ways. Having said that, if you want some additional instruction on how to handle compound interest, we cover it extensively in the Math Basics episode on percents, which is linked in the description for you. So let's explore the alternative we're given. We're told that if money is invested at R% interest, compounded annually, the amount of the investment will double in approximately 70 over R years. Well, we know the interest rate. It's 8%. They told us that. So why don't we just explore what 70 divided by 8 looks like? You probably can figure out that 70 divided by 8 is not going to be an integer result. And again, if you're just starting, integer means no decimals, no fractions. That's covered in the definitions episode of the Math Basics series. But that's where the approximate concept comes in. So 70 over 8, you might be thinking like, it's not an integer result, but the question says the approximate value. And so that means we don't necessarily need an exact result for 70 over 8. If we just want to find something close to the exact answer, then we can think about 70 divided by 8 a little differently than we might normally. So what's a multiple of 8 that's close to 70? 72. 72 is divisible by 8, and 72 divided by 8 is 9. So 70 over 8 is going to be just a bit less than 9. But because we don't need the exact value, we're just going to say the investment's going to double approximately every 9 years. We'll just use that. And that's really convenient in this problem because we're asked for the value of the investment in 18 years, which is 2 groups of 9. So looks like the investment's going to double twice. If we can get to that stage of the problem, it's not too tough to bring it across the finish line because we started with $5,000 and we're just going to double that. First double gets us to $10,000. Interest is compounding, which means it keeps getting calculated based on the new amount at the end of each year. So if we have $10,000 invested for another 10 years, then that $10,000 is going to double again to become $20,000. And that gets us to our right answer, which is option A, as in alpha. So if they started with 5,000, invested at 8%, doubles every 9 years. In 18 years, it'll double twice. It'll be worth $20,000. That last point about compounding is important because it looks like a decent percentage of us, about 8%, are going for option B, which is 15,000. And I'm not 100% sure why so many of us are picking B, but it does stand to reason that some of us might be thinking, oh, we added 5,000 in the first 10 years, so then another 10 years is going to add another 5,000. And that's not entirely right, even though it kind of sounds right. Like it kind of just seems to make intuitive sense. But when you put it under the examination of the compounding interest language in the problem, then you realize that's not the correct answer. So if that is how you thought about it, you'll just want to think a little bit deeper about what compounding means and update your assumptions for future questions. Again, we get a lot more in depth on that in the Math Basics episodes on percents, like I talked about. And again, like if you're missing these questions, I mean, first of all, it's probably going to be a lot harder to do them in your head if you're like driving or at the gym or something than if you're like at the desk with, the noise canceling headphones on or whatever. But that's all the more reason to do them this way. Like when you do them in this more challenging environment, it makes it even easier to do them when you are in a more focused environment. That's been my experience, at least. So don't fear being wrong, especially not here. If there's ever a time to be wrong, it's while you're practicing. And every question you get wrong in practice is a question you're probably not going to miss on test day. It's like an investment. So what I like about this problem is if you use that 70 over R approach, which is really just a specific example of the use what they give you in quant problems principle, and if you estimate, which is utilizing the when they say approximate estimate principle, you're probably going to get this one right, and you'll probably get it right relatively quickly. So abiding by those principles can be really, really helpful. In fact, those kinds of simple principles I have found are really the foundation of great quant scores. We've talked about a ton of those kinds of principles already in this series. I've, in fact, tried to make the whole series about those principles, but just using specific examples to illustrate them. Things like always write what's given and asked, like I mentioned earlier. Double check each step of the math if you're making computation mistakes. If you go back a few episodes, you'll hear me say that kind of stuff quite a bit. Even a lot of the content principles that we discussed in the Math Basics program. If you can practice using those principles enough, personally, I think it's surprising how much easier the quant section can get. Because, yeah, you're probably not going to, well, You definitely won't see these exact questions on test day, but the questions you see on test day are probably going to be very, very, very similar to this. That tends to be what happens with these standardized exams is they're standardized. So they're designed to change very slowly from year to year. So even practicing some questions that are a few years old, still representative of the questions that you're going to see today or tomorrow whenever you take the exam. So with all that being said, we may not be able to make the quant section feel easy. It is a challenging exam, especially because it adapts to your ability question by question, and it gets harder the better you perform. So it's probably always going to feel hard to some extent, but that doesn't mean we can't make it less hard by having like a good approach, a solid approach rooted in correct principles that scale. So that's what our goal for you is in this content. So hopefully that helps. And quick note about the whole adaptive thing. It is like quite unusual. Most of us haven't taken adaptive tests at this point in our life. So if you check out the video on our website, which I'll reference in a moment at the gmatstrategy.com, that'll help you understand how to manage that whole situation better. There's plenty more that we could say about these problems, but that's almost certainly enough for now. And we'll be circling back on all these principles as we continue to move up the difficulty chain and progress through the official guide together in future episodes. For now, if there's another note to self to make for you for this problem, I'd recommend pausing and making that note now. As always, we'll be back soon with more advice and tips to help you structure your approach to individual questions, help you structure your approach to the overall studying process and your individual study sessions. If you're just starting out, you might want to check out our episode on how to start your GMAT studies in 2025. The exam's gone through a couple major revisions in the last couple of years. That'll get you up to speed quite quickly there. It'll also give you an overall survey of the industry, what you can expect from different types of learning modalities and providers. If you're more advanced in the process and you're not just starting out, you might enjoy our episodes on how to build speed or how to score high consistently, especially if you're seeing a lot of variance in your practice test scores. We'll link those episodes below for you as well. If you have any questions at any point, feel free to reach us at the GMAT Strategy on current social channels, or you can email us at contact, CONTACT, at thegmatstrategy.com. And we like hearing from all of you, and we're here to help. We're here to support. In the meantime, if you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. It's basically a bunch of stuff that I wish someone sat me down and told me. It doesn't translate super well to audio format, so that's why we did it in video form, and really hope that helps you as much as it helped me out. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.